In this video, I will share my weight painting process while showcase handy weight edit, add-on functions. To install it, you can install from preference, or simply drag and drop in Blender. Here I have a cube, an armature, with a few key poses. To better explain the weight painting basics, bind the mesh to the armature with empty groups. Turn the vertex weight toggle on, go to mesh edit mode, and start weight painting. Since the initial weight is 0, it displays as black. There is no influence on vertices. But as soon as I add some weight to selected vertex, it starts to move. Higher the value, bigger the movement. At maximum value of 1, it displays as red. Switch to a different bone, modify vertex weight value, it starts to move with that bone. When a vertex is influenced by multiple bones, the vertex movement depends on the mixed weight value of each bone. You can turn on active vertex weight groups to check a single vertex weight value by all relevant bones. Adjust and balance weight value for each bone to achieve a proper mesh deformation. In a nutshell is weight painting. Before we start, I'd like to mention a few things that could make the whole process a lot better. Edge flow matters. In these two mesh, with different mesh topology, the deformation on the left is much better than the right one because of the better edge flow. Bone location matters. Just move the bone location a bit, you can see the mesh deformation is quite different. Bone naming convention matters. Proper bone naming is required to mirror weight. Familiarize yourself with common Blender tools. For example, Loop Select, Grow or Shrink Select, Patch Select, Lasso Select, Toggle X-ray to select through mesh part, Hide mesh part. It is recommended to assign them as hotkeys. Here I have an armature and a human mesh. I have keyed some pose where bone rotates to its limit. First select the mesh, then select the armature, parent it with automatic weight. At the time of recording, there is a display bug since version Blender 4.4 which messed up the armature's in front effect. If you are watching this video in the future, this may or may not be fixed. If the bone in front effect does not display properly, you can turn on the custom bone highlight. Go to Add-on Preference and turn it on. At active bone location, a new highlighted stick is drawn. This better represents which and where active bone is. You can adjust the color and width of it. When Isolate Active Bone toggle is on, or use Switch Bone operator, it is automatically adjusted. After binding mesh to armature, turn on Vertex Weight toggle, go to Edit mode and it is ready to weight painting. Under Common Ops, those are mainly used with hotkeys. First select vertices, then use desired ops to add or reduce weight. The Fill method modify same weight amount on all vertices, whereas Gradient method is on a per vertex level. Smooth weight will smooth the selected vertices' weight value with regarding to their adjacent vertices. To switch to different active bone, use Switch Vertex Group operator. If a single vertex is selected, it will cycle all its influenced vertex groups. Otherwise, it will sample the max influenced bone under mouse cursor and switch to it. To better visualize it, turn on Toggle Bone's name and isolate active bone. Another method to switch active bone is to use Switch Bone operator. It calculates the closest bone under mouse cursor and switch to it. Under Miscellaneous, add or reduce weight increment can be changed. When use the Scrub Timeline function, there are 3 dedicated zones. X, Y, Z, for rotating active bone in different axes. Move mouse to each zone, press and hold the hotkey, then move mouse left or right would rotate the active bone. Release hotkey to end operation. Double-click hotkey to reset active bone. While outside those zones, it will scrub the timeline. Use Reset All Bones rotation to set armature to default. Change Scrub Multiplier to adjust scrub timeline speed, and Rotate Bone Multiplier for bone rotate speed. Use Import, Export Weight as save point. It uses mesh name as file name and will overwrite existing file. Change object name when needed. Start from the head. This is the easiest part. because most of the head should only be influenced by the head bone. Use smooth weight to smooth out the sharp transition. Although head bone influence is set to max, there is still minor distortion. Switch to neck bone, it also has influence on some vertices. This introduces a concept of normalized weight. Select a vertex and turn on active vertex weight groups. You can see although head bone has weight value of 1, neck bone has about 0.2 weight value. When average out the ratio, head bone actually have about 0.8 weight value, thus the minor distortion. Turn on auto normalize toggle, back to head bone, add weight. Now switch to neck bone. You can see its weight is auto adjusted. This is how auto normalize works. For beginners, you can turn this off, so that it is easier to understand how much influence each bone has. Other body parts like finger, lower arm, lower leg and feet, are the same procedure. Mostly set max bone influence and smooth out transition. When it comes to shoulder area and pelvis area, things become a bit tricky, because these vertices are often influenced by more than 3 bones. Take shoulder for example. I think the upper arm has too much influence in the torso, so select some vertices and reduce weight with gradient method. Switch between upper arm bone, shoulder bone, and spine bone to adjust the weight till you get reasonable deformation. Same thing with pelvis area, switch active bone, select vertices, scroll weight, check deformation and repeat till pass visual inspection. When half of mesh weight is finished, time to mirror weight. To check if mesh is perfectly symmetric, select half and move around. If other half is moving in opposite direction, then it is perfect symmetry. Select the other half of mesh and use mirror weight to transfer weight to other side. If not, there is option 2. Although mesh is not perfectly symmetric, but is symmetric proportion-wise. Select mirror direction, choose active bone or all bones and mirror weight. This method uses close proxy, so for area that close to each other, some manual fix may be required. At this point, mesh deformation seems to be okay. If the target platform is Blender, it could be considered done. However, if the target platform is Game Engine, additional tweak is required. For a given vertex, the more bone influence it has, the heavier computation is, hence may be slow at runtime. To optimize it, set the max vertex group number. Use check exceeded groups to find any vertex has more than set amount. Use vertex group limit to remove small weight value groups. For very small weight value, its influence on mesh deformation is barely noticeable. Set the minimum amount and remove weight could also optimize the asset. Last but not least, use check weight sum to find any vertices that are not normalized and use normalize weight to set total weight value equal to 1. Game Engine requires that. For a simple character rig like this, no matter how much time spent in weight painting, there is always limitation. For example, if I rotate the leg sideways, weight paint alone cannot do the job. So one option is to use corrective shape key. Another option is use advanced rigs such as Unreal MetaHuman, where there are many secondary bones to adjust the abnormal deformation. Also, download free sample from Blender Project and Unreal MetaHuman site. Study their weight distribution, learn from the experts. This concludes the introduction video. Happy blending!